First of all, this is alpha. Okay, it's almost like when you make a goldfish, but you just kind of deleted the tail. Okay, alpha is the first Greek letter in the alphabet. It's lowercase. All right. We have this problem right here. Notice there's an obvious ugly side, right? This is the ugly side right here. There's a big plus and there's signs and causes everywhere, and there's pluses and there's pluses in those pluses. And on top of that, we're going to prove this is cosecant. Wow. Okay. So what is the common denominator for the left side of the equation? So in other words, looking at this right here, and in particular, looking at just the bottom, what is the common denominator going to be? Why? Well, we need each part from the denominator, right? So this part is missing the sine alpha. This part is missing the 1 plus cosine alpha. So I need both parts to make the entire denominator. Okay, looking at the first fraction, so let me go ahead and looking at the first fraction, we have sine of alpha over 1 plus cosine alpha. So if I multiply this by sine, I do the top as well. And this becomes sine squared theta. Sorry, sine squared alpha. And don't distribute these. I mean, you could, but in doing trig proofs, you're usually better off not distributing things because they actually might end up canceling out at the end. So that's the first fraction if we go ahead and make a common denominator out of it. The second fraction was 1 plus cosine alpha over sine alpha. And we end up multiplying this by 1 plus cosine alpha. You'll notice that I have two of these up here. So this ends up becoming 1 plus cosine alpha squared over sine alpha 1 plus cosine alpha. We haven't even officially began yet. We're just looking at the common denominators. We're trying to piece that out together. And I thought it might be beneficial to you if I do this as a two-column proof, like you're used in geometry. So I'm going to have the statements, and I already gave you the reasons, right? So obviously we said that LCD, right, lowest common denominator. Okay, that's going to be sine squared alpha over sine. Okay, so we got that from above. If we add the numerators, then we end up simplifying this a bit. We're going to expand 1 plus cosine alpha squared. So if we do that, side note, that is 1 plus cosine alpha times 1 plus cosine alpha. If you distribute that, you have a cosine alpha plus another cosine alpha. That's 2 cosine alphas. Why are those 2 and not squared? It's squared when you multiply. So here it was cosine times cosine is cosine squared. Here you're adding cosine plus cosine. So if you're multiplying, multiple numbers of a trig function, then you're going to end up using a power for that. But if you're adding multiple cases of trig functions, then you're going to just add a coefficient to that. So cosine plus cosine, for example, would be 3 cosine. But cosine times cosine would be cosine to the third power. Okay. Wow. So that became that. So I got sine squared alpha, right? This is the original one. Let me go ahead and I'll make this orange for you. I'm going to actually write this as cosine squared. I'm going to put this in descending order. So the square will be first, then the 2 cosine alpha, and the 1. So I'm going to put that in place of this thing right here. This will be replaced by this new thing that we made. Cosine squared alpha, 2 cosine alpha. Wow. Check this out. Sine squared plus cosine squared is what? You notice that it's 1 plus 1. So I'm just going to add the 1 plus 1 that gives me a 2. So it's 2 plus 2 cosine alpha over that whole thing. They both have a 2, so I'm going to go ahead and factor out a 2. Now, when you factor out a 2, in case some of you are struggling with this, if it helps, you could put 2 times 1 right there. Okay? So when I factor out a 2, that means I'm taking out the 2. That means this one is gone, and this one is gone. And that's why I have a 1 plus cosine in the inside. You can always check, right? If I distribute this, you should get the original problem. Okay, this is extra in case if you're wondering why. I was just showing you extra in case if you need to know why. Okay, great. Look what happens here. This is amazing. This is the same as the bottom one, so these cancel out completely. I'm gonna separate this. So the 2's on top and the sign's on the bottom. This over 1, this over 1. 2 over 1 is 2, and 1 over sine is cosecant. For your summary, what are some algebra skills you will need to brush up on? No joke.